How you guys doing? I'm Mr. Kamiyama, and I'm here to show you guys today, quickly and briefly, how to multiply monomials. All right. Now, if we look here, what we got three monomials on the board here. We got 2p to the third power. Okay, that's one monomial being multiplied to 3p to the second power times 3p to the third power. So what we're going to do is we're going to take these monomials, we're going to multiply them together. All right. Now, how we do this properly. The first thing that we want to do is we want to look at all our coefficients. Now, what's a coefficient, you may be asking? Okay, any number that's sitting in front of the variable. So we got this 2 right here that's in front of the p to the third power. Okay, so we got to take a look at all these coefficients. We got a 2, we got a 3, we got a 3. And what we're going to do is we're going to take these numbers. And because we got multiplication symbols in the middle of each of these terms, we're going to multiply them. So look at what we do. First step. So I take this 2 right here and I multiply it to this 3 and I multiply it to this 3. Now what is 2 times 3? 6. And what's 6 times 3? Because we did that. So what's 6 times 3? 18. So now we got 18. That is going to be our coefficient for our answer is 18. Because 2 times 3 is 18. Now, what do we do with these exponents? Okay, now take a look. All we have to do is look for the variables that are the same. Okay, so let's look for the variables that are the same. What variable do we have here that's the same in every single one of these monomials? P. So I'm going to put a P here. Just one. Now, what I got to do is I got to figure out what exponent I'm going to raise that P to. What power is going to go to that P? This is all you do. Listen to me. Very, very simple. What you do is in the problem, you look at all the exponents go with the P. So here, I got P to the third power, so there's a 3. P to the second power, so there's a 2. And P to the third power, so there's a 3. And what I do is I take each of these exponents and I add them together. So look, I take this 3, add it to 2, add it to 3. So see, I'm going to add these exponents up. And what I get when I add those exponents up, 3 plus 2 is 5. 5 plus 3 is 8. So that means I'm going to have 18p to the 8th power. And that's it. That's my answer. 18p to the 8th power. Now let's just recap real quick what we did. We took the numbers that were in front of the variables and we multiplied them. 2 times 3 times 3 is 18. Then we took the exponents that went with the variables that are the same. The variables have to be the same in order to add these exponents. We got 3 plus 2 plus 3, and that's 8. So that is my exponent of 8. And that's it. What we did is we properly multiplied those monomials. Now you may be thinking, well, yo, Kamiyama, what's up? What happens if the variables aren't the same? Well, that's going to change things up a little bit. So let's take a look and see what's going to happen there when we have that change. So let's take a look. What about if we got a problem that looks like this? What if we got 2y x to the 4th times x to the 4th y to the 3rd? Okay, it's a little bit different. Okay, it looks a little bit longer, and that's okay. Now, how many monomials we have here? 1, 2. We got 2 monomials here we're going to multiply together. Now, the first thing is I said you're going to take the numbers in front of the variables and multiply them. You got a 2 here, but what's in front of the x? There's nothing there. Now, if there's nothing there, what can you always put in front of that variable? You can always put a 1. So I'm going to go ahead and put a 1 there. Now somebody tell me, 2 times 1 is what? It's 2. Remember, you need to make sure that you multiply the numbers in front of the variables. Do not add them, okay? You multiply because you are multiplying. But now, let's take a look at those exponents. The variables. So I got a y here and a y here. So I know I'm going to have to put an exponent to the y, but this y is chilling all by itself. There's no exponent with the y. Now remember, just like we put a 1 in front of the x, we can also put a 1 for an exponent for this y. Y and y to the first power are the same thing. So if it makes it easier to put a 1 for the exponent, go for it. Now how many y's do you really have? You have 1 y here, and you have 3 y's here. 1 plus 3 is 4. Now, so we got the 2 and the 1 taken care of. We got the y's taken care of, but now we got to deal with this x. Now, what exponent are we going to raise the x to? Well, let's see how many we have. We have 4 here, and we have 3 here. Now, 4 plus 3, 7. So we put a 7 here. Now, that's it. That's our answer. 2, y to the 4th, x to the 7th. Now, I will tell you all this. You guys may have a teacher who say, wait a minute, this isn't right. This is kind of sloppy. You know why they're saying that? They're saying that because if you know your ABCs, A, B, C, D, and so on, you should know that X comes before Y in the alphabet. And when you are writing monomials or polynomials or something like that, what you want to make sure is you want to try in your answer to put your variables in alphabetical order. Okay? It's pretty simple. Y'all should know your alphabet by now. So because we said that X goes first, our final answer could be this. 2 x to the 7th, y to the 4th. Now, some teachers will say that's better. It'll make them feel better that the stuff's in alphabetical order. I mean, technically, these two answers are identical. Okay, because remember with multiplication, you can move stuff around, right? Commutative property multiplication. So you can move stuff around, but some teachers just like this better, okay? Makes them feel better about themselves, all right? So anyway, so that's how you would do a problem like that when you got 2 variables. Now you may say, hold on, wait now. What if we got 3 variables? Ooh, let's take a look, see what that's gonna look like. Here we go, let me erase this right quick. All right, now let's take a look. So how's that gonna look? Let me show you real quick. What if we got something like this? 3n p to the 3rd times 4m to the 3rd p to the 3rd times 4m squared n squared p squared. Look at that problem. Isn't that a nice one? It's a beautiful problem. All right, so let's take a look and see if we can answer it quick like. First up, what do? We take our numbers in front of the variables and we multiply them. Once again, you have to multiply them. So let's go. I got 3 times 4 times 4. Now you may say, whoa, that's a big number. It's not that big, people. 3 times 4 is 12. 12 times 4 is what? 48, okay? It wasn't that bad. Now let's take a look at those. Look at the n. Now, oh, wait a minute. What should I put with the n to make it easier? A 1, that's right. So I'm gonna put a 1 there. Okay, so how many n's do I have in my problem? Let's take a look. N to the, there's 1. None there. Oi, and 2 there. What's 1 plus 2? It's 3. So I put a 3 here. All right. Next, we got the p. How many p's do we got? Right? We got 3 here. We got 3 more there. That's a total of 6. And look at that. 2 more there. So 6 plus 2 is 8. So we got a total of 8 p's there. Now, what about, so we got the n, we got the p, we're good. Do we got any more variables up here we can write down? Because don't just look at the first term. Okay, you got to look and see if there's any other variables there. Let's look, any different variables besides n and p? Oi, got an m, so put an m here. Now, how many m's do we have in this problem? We got m to the 3rd, and we got m to the 2nd. 3 plus 2 is 5, so we got m to the 5th power. Okay, now, are we done? Yeah, I mean, technically, yeah, we're done. But maybe we should try to put these in alphabetical order to make sure that our teacher don't get mad at us, right? Because I don't know, this is the Kamiyama way, but maybe it's something different with a different teacher. So here we go, watch. Start off with the 48, because that coefficient just goes first all the time. Now, what comes first in the alphabet? N, P, or M? M. So that's going to be M to the 5th. Then what? M, N, O, P, right? So N comes next. That's going to be 3. And then P is going to be 8. And look at that. That's our answer right there. All right? So what it is again? 48, M to the 5th, N to the 3rd, P to the 8th. Just like that. That is how we're going to multiply monomials. Okay? Now, there's going to be another part. It's going to get a little more difficult. All right? But for right now, this is all we're going to be working on. Okay? So I hope this video made sense. I hope y'all understand how to multiply monomials. Okay? Because it's important. We're going to be going sequentially in steps to get y'all to understand the exponent rules. All right? So hope y'all got this. Thank you so much and have a great day.